Hello and welcome back to BlessedMath. So we are in part 3 of solving systems of equations and inequalities. In our last lesson, we went over how to solve a system of equations using elimination method with two techniques such as addition and subtraction. So in this lesson, we're going to dive a little deeper and go into multiplication and using multiplication and addition combined. Remember, you can visit us at www.blessedmath.com. We are your Atlanta-based tutoring resource. So, we're going to be dealing with more techniques for solving systems of equations. So our little fighting ninjas are back, and we've eliminated one of the variables. Using multiplication. When we have two systems of equations, two equations in one system, the line 3x plus y equals 2 and x plus 2y equals 4, we want to eliminate one of the variables. So let's eliminate the x. We notice that if we multiply the second line, x plus 2y equals 4, by negative 3, we will end up with a negative 3x as our first term. And we do that because negative 3x plus 3x is equal to 0. So we take the first line, 3x plus y equals 2, and the second line we multiply by negative 3, and we end up with 3x plus y equal 2, and negative 3x minus 6y is equal to negative 12. Now we can eliminate the x variable since they have competing coefficients by adding. 3x plus negative 3x is 0x or 0. And y plus negative 6y is negative 5y. 2 plus negative 12 is negative 10. Now we can solve for y. Simplifying, we have negative 5y is equal to negative 10. We will divide by negative 5 on both sides to cancel out the leading negative 5 coefficient, and we end up with y is equal to 2. From here, we substitute the 2 for y in either equation so we can solve for x. So instead of x plus 2y equals 4, we actually have x plus 2 times 2 is equal to 4. And simplifying, that's x plus 4 is equal to 4. When we subtract 4 on the left and the right to get rid of the 4 on the left-hand side of the equation, we end up with x is equal to 0. This means that the point 0, 2 is the solution of the system. When we have negative x plus 2y is equal to negative 4 and negative 2x plus 3y is equal to negative 2. So let's go ahead and try to get a positive 2x in the first equation. So we're going to multiply it by negative 2. Negative 2 times negative x plus 2y equals negative 4. And we're going to keep the negative 2x plus 3y equals negative 2 in the second equation. When we distribute that out and finish multiplying, we end up with 2x minus 4y is equal to 8. And we're going to add negative 2x plus 3y is equal to negative 2. And we're adding because we're going to cancel out those x's again. Positive 2x and a negative 2x gives us 0. A negative 4 and a positive 3y gives us a negative y. And 8 plus negative 2 gives us a positive 6. So we're going to solve for y. Simplifying, we get negative y is equal to 6 divided by negative 1 on both sides, or multiplied by negative 1 on both sides, results in y is equal to negative 6. Substituting negative 6 in for y, in the first equation, we have negative x plus 2 times negative 6 is equal to negative 4, or negative x simplified minus 12 is equal to negative 4. When we add 12 to both sides, we get negative x is equal to 8. In which case we have to divide by negative 1 or multiply by negative 1 to get x is equal to negative 8. So we say the point negative 8, negative 6 is the solution of the system. We're going to use more than one equation, which means we might have to multiply both equations to find something that's common. So let's start off by choosing a variable to eliminate. We'll choose x. So we have 3x and 2x. Well, what number can 3 multiply into and 2 multiply into? How about 6? So we're going to multiply the top equation by a 2, and we'll multiply the bottom equation by a negative 3. This gives us 6x plus 4y is equal to 10, and negative 6x minus 12y is equal to negative 18. we can add them together and eliminate the x's. 6 plus negative 6 is equal to 0x. 4 plus negative 12y is negative 8y. And 10 plus negative 18 is negative 8, leaving us with negative 8y is equal to negative 8. Dividing by negative 8 on both sides, we get y is equal to 1. Substituting that back into the second equation, we have 2x plus 4 times 1 now is equal to 6. Simplifying, we have 2x plus 4 is equal to 6. We subtract 4 on the left, subtract 4 on the right. On the right, we have 2x is equal to 2, and we divide by 2. It gives us x is equal to 1. So we can say the point 1, 1 is the solution of the system. And remember that if you plug it back into both equations, so if you check with the first equation, 3 times 1 plus 2 times 1 is equal to 5. That is true. The second equation, 2 times 1 plus 4 times 1 is equal to 6. That is true. All right. Let's try again. 3x plus 6y is equal to 12, and x plus 4y is equal to 6. Let's try to eliminate the y's. So we're going to ask what numbers can we multiply into the 6 and the 4 to give us a common number. And we know 6 times 2 is 12, and 4 times 3 is 12. So we're going to be dealing with 2 and 3. So let's multiply the top equation by negative 2 and the bottom by 3. That gives us negative 6x minus 12y is equal to negative 24. And we're going to be adding 3x plus 12y is equal to 18. Well, negative 6x plus 3x is negative 3x. Negative 12y plus 12y is 0. And negative 24 plus 18 is negative 6. So let's go ahead and solve for x. Negative 3x is equal to negative 6. We divide by negative 3 on both sides. It gives us x is equal to 2. Substituting that back into our first equation, we have no longer 3 times x plus 6y equals 12, but we have 3 times 2 plus 6y is equal to 12. 3 times 2 is 6. 6 plus 6y is equal to 12. We subtract the 6 on the left. 12 minus 6 is 6. 6y divided by 6 and 6 divided by 6 leave us with y is equal to 1. So that tells us that the point 2, 1 is the solution of the system. Join us next time as we begin our systems of equations and inequalities in Lesson 4, dealing with solving systems of inequalities. Again, you can visit us at www.blessedmath.com. We're your Atlanta-based tutoring resource, and you can visit our website to get in contact with some of our amazing math tutors.